Hi everybody, Dr. Ricardo. I had promised you I would do one question where we used the colligative properties to calculate the molecular weight of an unknown substance. So I have a question from an older textbook that we're going to do together. It's probably a short video, hopefully less than 10 minutes. Good, you know me, I can talk, so it might be more than 10 minutes. So let's go through this question. We're going to do 12.66 from an older textbook. So butylated hydroxytoluene is used as an antioxidant in processed foods. It prevents fats and oils from becoming rancid. A solution of 2.50 grams of BHT in 100 grams of benzene has a freezing point of 4.880 degrees C. Okay, so the freezing point of the BHT solution, right, comes out of this question, and it's 4.880 degrees C. I looked up the freezing point of pure benzene from your textbook. It's 5.5 degrees C. And the last thing we need to look up, and we're going to get it from the same table. So these two things are going to come. This comes from the question, and this guy is going to come. This is going to come from the table in your book. Okay, is we need what is KF for benzene? Right, it has nothing to do with the BHT. All benzene has the same freezing point depression constant. Okay, so here's your book. This is at the bottom of page 546. All right, here's benzene. Its freezing point is 5.5. Its freezing point depression constant, KF, is 5.12. Okay, so 5.12 degrees C for each molal. Okay, for each molal. All right, so given this from the table and this from the question, what's the first thing that we can calculate? Well, we can calculate how much delta H has been depressed, right? How much the freezing point has to be depressed. Well, the freezing point is supposed to be 5.55, but it's only 4.88. So it's been depressed by that difference. Okay, so 5.5 degrees C minus 4.88. So you're kind of working backwards. Okay, this only has one place after the decimal. This guy has too many, so we're going to round to just one place after the decimal. So I got 5.5 minus, unless the book gave me one more on there. No, they only gave me 5.5, so I'm going to have to deal with that. Okay, so 5.5 minus 4.480. Okay, so how much was the freezing point depressed? It was depressed by 0.62 degrees C, and I have that guy to two significant digits. So my answer, really, I'm only going to have to two significant digits, so I'll have to round it at the end. So I'm only going to be able to approximate the molecular weight to two significant digits. Okay, but I'll deal with that. Okay, so that's how much the freezing point was depressed. Okay, so the next thing that I have that I'm going to put on the side is I need to figure out what is the molality of the solution, right? So first, let me write down my formula. If I want to take my freezing point depression is always equal to three factors, right? It's equal to the freezing point depression constant, right, times the molality, right? And we might as well put our I in there too, because I is going to be 1. This BHT is an organic compound. It's a molecular compound. I would be equal to 1. It's not, we don't expect it to ionize in any way. So I have 1 times the molality times the freezing point depression constant, KF. Okay, well I have this, and I have this. The only thing I don't have is the molality. So that's what I'm actually solving for. Then when I have the molality and I have how much benzene I used, I'll be able to get the number of moles. So that'll be the next step. Okay? All right. So let's solve this equation for molality. So the molality is going to be equal to delta TF divided by I times KF. So I'm going to plug in. I have 0.62 degrees C divided by 1 times my KF. And my KF was right here. 5.12 degrees C per molal. Okay, so my molality, degrees C will cancel out. I doesn't have a unit, so I get molality in the bottom of the bottom. That's going to kick up to the top. So it's just going to be 0.62 divided by 5.12. Okay. So my molality is 0.12. Okay. Again, just this guy had 2 significant digits, so I really should only have 2 here. Okay, 0.12 molal. Okay, what is molality? Well, if you remember, molality is moles of solute divided by kilograms of solvent. They did tell me how many grams in the question, right? How many grams of benzene I had. I had 100 grams of benzene that I dissolved my 2.5 grams of BHT to. So I'm going to use that right now. Here's my 100 grams of benzene. This is the mass of the solvent. Okay, so that's going to go down there. All right, what does that translate if I change it to kilograms? That's 0.1, right? 100 divided by 1,000 gives me 0.1 kilograms. Well, lucky I have so many significant digits, but not really going to help me. So I have this, right? And now I have this. So what am I solving for? Rearrange this guy for the moles of the solute. So the moles of the solute is going to be the molality times the kilograms of solvent. So the moles, this is the second to last step. Sorry about that. The moles of the solute is going to be equal to the molality. This is moles per kilogram of solvent times the kilograms of solvent, which was 0.1. Oh, yep. Kilograms cancel out. How many moles of BHT do I have? I don't know exactly what the structure is. We're just calling it BHT. It's going to be 0.012. All right, last step. Moles of BHT. All right, anytime, this is the key, right? Anytime I know the mass of something, because I originally weighed out my BHT, and I independently know, from a totally different experiment, the moles, okay? So I independently know this from doing my experiment with freezing point depression. It had nothing to do, I didn't weigh it out, okay? Can't get it from the same place, so I know the mass, and I independently know the moles. Well, if you know the mass of something and you independently know the moles, you can calculate the molar mass, because what is the molar mass? It's the ratio of grams per mole. So you're just going to take this guy divided by that. So let's go back up and look at the question for a second. The question said I had 2.500. Wow, these guys gave me so many significant digits except for the one place that I need it. It said 2.500 grams of BHT. Okay, so there's my two numbers, right? And remember, what is the definition of molar mass? Molar mass is grams of something per mole. I know these two things from two different places. The grams was easy. I just weighed that out. The moles, I calculated the moles I calculated from doing this freezing point depression experiment. So grams per mole, they're both for BHT. So I'm going to wind up with the molar mass of BHT is equal to 2 divided by 0.012. 2.5, sorry, 00, divided by 0.012. Okay, 208. And the only problem is too many significant digits. So I have 208, that still has 3. That has a lot more meaning to us in science when we think about it that way. This is grams per mole. If I really wanted to report it right, I should put in scientific notation though. 2.1 times 10 to the second grams per mole. Okay, that's better. That has the right number of significant digits, because this guy back here, this subtraction left me with only 2 significant digits. So really it should have given me 5.50. If I had one more thing on the boiling point of the pure benzene, I would have been okay. I could have kept one more 0 here after that. Okay, but good enough. It's about 208, which makes sense to me. Okay, so this is an example. I'm going to put it all up. This is an example. You could do this with any of the colligative properties. You can use the colligative properties to calculate the molar mass of an unknown substance. Okay, as long as it's pure. So you take the unknown substance, you weigh it out. You put it in a known amount of a solvent. You do the freezing point depression experiment, the boiling point elevation experiment, the osmosis experiment, and you use that to calculate the number of moles of that material that you don't know what it is, but now you know how many moles of it you have from the experiment. And lastly, you couple that with this crazy important formula from Chem 1, right? That the definition of molar mass or molecular weight, okay, this would be better, molecular weight, or molar molecular mass. Okay, molar mass. Okay, all the same, right? You know how much grams you had, okay? And you also know from the experiment how many moles you have, and you just take the ratio of those two things, and you'll be able to calculate what it is that you have. What is its molar mass or molecular weight? Okay, 13 minutes, so I went 3 minutes over. Sorry about that.